13. So we have a right angled triangle whose coordinates are O, which is the origin, point N, which has the x value of x and a y value of 0, and point M directly above N, which will have the same x coordinate of x and a y coordinate of y. The y coordinate, of course, can be obtained by getting the equation of f prime, which is given to me and which I have rewritten in y form. So y is equal to negative 3 over 2x plus 3. So that will be the y coordinate at point M. So the first thing we're going to do is we're going to work out the x value, and I'm going to call that x1. That gives us a maximum area for triangle OMN. So recall, the area for triangle is half base times the perpendicular height. The base is ON, which is x units, and the perpendicular height is the length MN, which is basically the y coordinate at M, which is negative 3 over 2x plus 3. I can now distribute the half x inside the bracket and get a formula for the area of the triangle. It's going to become negative 3 over 4 x squared plus 3 over 2x. Now to get the maximum area, we make the derivative equal to 0 and solve for x. This will give me negative 3 over 2x plus 3 over 2 is equal to 0. And if I solve for x, I get x, which is equal to x1, is going to be 1. We're now going to try to get the value x2, which gives me the maximum distance between f and f prime. So I have the equation of f already. I have the equation of f prime already, which is f prime, which is a straight line. That's given as negative 3 over 2x plus 3. And in order to get the equation of f of x, we simply integrate the equation of f prime of x. So we can do reverse derivative differentiation. We're going to get minus 3 over 4 x squared plus 3x plus some value c. And in the question is also told that the stationary point of f is at x5, which means the y value is 5. And then we also know that at the stationary point, the derivative of f will be 0. That's going to be where the graph of f prime touches the x-axis. So that's going to be the x-intercept of my straight line. And if I set y equal to 0, I'm going to get an x-coordinate of 2. So the coordinates here are going to be 2, 0. So the stationary point is going to be 2 and 5. So 5 is equal to negative 3 over 4 into 2 squared plus 3 into 2 plus c. And if I solve for my value for c, I get c is equal to 2. Now to get the maximum distance between f and f prime, we take the equation of f minus the equation of f prime, and we're going to make the derivative of that equal to 0. The equation of f we just got is going to be negative 3 over 4 x squared plus 3x plus your c value is 2 minus, and the equation of f prime was my straight line, negative 3 over 2x plus 3. And if I simplify this, we're going to get negative 3 over 4 x squared plus 9 over 2x minus 1. I can now make the derivative of this equal to 0. And if I do that, I'm going to end up getting negative 3 over 2x plus 9 over 2 is equal to 0. And if I solve for x now, which is my x2 value, I'm going to get x2 is equal to 3, which is a different answer to what I had before. So the answer is there will not be the same x value.